Hi, I'm Mike Lombardi. I'm a software engineer at Puppet. I spent a lot of the last half decade or so managing legacy code, writing legacy code, triaging legacy code, both as an IT pro and then later on as a developer. The tempting thing to do, of course, is just take all the legacy code and throw it out the window. But it turns out, for unknown reasons, you can't do that, right? So what are those reasons? Turns out every piece of legacy code that exists in your environment is proof that your company is currently successful to the point that it still exists, right? Like the only company that doesn't have legacy code is the company that was formed today. Because if it was formed yesterday, you wrote code and it's all legacy already. So the best practices that you had 8 years ago when you were solving those problems, all that stuff's changed, right? Like the world has moved on, winter has come. And there's a lot of value that's trapped in those systems. There's a lot of stuff that it does that we find really useful, such as we all still get paychecks, right? Anybody here not getting a paycheck from work? Anybody not getting a paycheck and still going to work? That seems bad, right? Okay, so those systems, by the way, are almost exclusively legacy systems. But legacy code also contains lessons about our organizations over time, right? When we solved that problem in the first place, we had a particular context that we had to solve for. That context might be the same now, but almost definitely isn't, right? So what do? We have all this stuff. It kind of hurts. It's painful. What we need to do to manage it, right? Because everybody, okay, before I go into what triage is, does anybody here have legacy code they're happy about running in their environment and no legacy code that they're upset that runs in their environment? That's not a lot of hands. Like nobody, you have perfect legacy code, you're happy with it, it feels safe. It's good. Hands up if you've got legacy code that's running in your environment right now that kind of makes you nervous. Yeah, I kind of thought that might be the case. All right, so triage, let's talk about what triage is real quick. This is a workflow tool that was actually pioneered in the medical industry. It goes back to a word called trier, which is French, which means splitting things into 3 buckets, right? So they wanted to prioritize the injured and the sick into 3 buckets for like people who need attention now, people who need attention later, and people that don't need attention. Don't need attention could be you're fine or you died. So like that's not necessarily the bucket you want to be in. It can be, but it might not be. But triage is not just about ordering, right? Because there's a lot of trade-offs that go into it, right? So if you're bleeding right now, I can put a tourniquet on you, and that might be all that you need for the next hour or 2 hours, and there's other people who need more immediate attention. But it talks about whether or not you can come safely back around for future aid, or if you need to stop everything and work on it now, whether it's advisable to even treat them, right? Because there are sometimes where people are too sick or too injured, there's just nothing you can do for them, right? And in a catastrophe, it's a terrible decision to have to make, but you have to help the people that can be saved. It's the same thing with our code a lot of the times, right? There's stuff that's just too expensive and hard to deal with. But the point here is that it's all about trade-offs, and they're not easy. So there's 3 categories that we're going to talk about today when we think about triaging our code. Kind of following after that, we're going to talk about dependable, right? So this is the stuff that you know right now. It's pretty safe if you do nothing. It runs fine. There's people on your team who sort of understand it. They're able to kind of manage this. You don't feel like it running in your environment is going to burn you really badly in the next 6 to 12 months. There's the stuff that you should defenestrate. It's absolutely unsalvageable, even with intervention, and we'll talk about what you can do around that. And then the one that we're going to really focus in on today is doctoring, which is stuff that it's relatively safe if you can get some prioritized intervention in place. Something to keep in mind, these are rough groups. It's not perfect. It's always contextual. It always depends on your organization, your business, your team, your resources. So how do we begin to assess this stuff, right? We want to build up an idea of like a 3-fold check, right? Risk to value to maintainability. Those are the 3 things that we're going to really want to like look into because that determines whether or not we intervene, right? And we're going to dial this in over time as we triage more scripts. All right, so your first ones, they're going to be really rough. You may not have a really good idea, but as you do more of this, you get a better feel for it, particularly in the context of your organization. So first thing you want to ask is how many things does this do? If it does one thing, it's probably relatively easy to triage, right? Does one thing, it doesn't connect to a whole lot, that's relatively safer. The more things it touches, the more that risk goes up, right? How many systems does it actually get involved with? So if it does a lot of things to one system, that's safer to mess with than a lot of things to a lot of systems. That risk, again, kind of goes up, but so does the value typically, right? You did this to solve a problem. How valuable is it overall? What is it actually doing? Is the thing that it's doing still driving business value, right? So if you have a script in place that was absolutely necessary to get you through a security audit 2 years ago, and you've mostly trued up since then, and you run it every now and then anyway, and it's brittle and kind of scary because it's messing with AD properties, do you still need to run it? Is it still as valuable as it was? How impactful is it? If this thing breaks or goes wrong, what's it going to do to your environment? What's that going to look like for you, right? So you see this a lot. We don't think about telecom as being super duper important. Does anybody here have like a telecom at work? Like you have a team dedicated to it, right? Okay, does anybody here have sales organizations at work? Like people who do sales, right? How do you think they feel when those phone lines go down, right? That becomes like a critical, everything else in the organization will stop right now until that's restored. We don't think of it that way, but it is incredibly impactful. Also a legacy system typically. And then how many people understand this? So this talks to that maintainability problem, right? Very often, legacy code was written by somebody who isn't in the room anymore. Does anybody here have to maintain legacy code that was written by somebody who quit more than a year ago? Yeah, like everybody, okay. So that being the case, what that problem brings up to you is that now you have a thing that nobody really understands exactly how and why it was implemented, and typically there's comments that were left that make sense only to that one person, which isn't super useful for us. And one of the things that we need to understand when we go into triage is not just what is it doing, but why is it doing, right? So there's a lot of systems where they'll make a single line update, they'll do something to a database every 2 weeks. Why? I don't know. Do you know? No, we don't know. Who knows? That one guy. Well, let's ask him. Yeah, he retired to a fishing boat 5 years ago. I don't think he's going to answer the phone. So this is all the stuff you need to think about. Again, remember, these are trade-offs. You're building kind of like a rough idea of how valuable to how risky to how maintainable. And they're rough buckets, right? You're going to update this over time. So let's talk about when it is good to throw things out the window. And the first thing to say is that it's okay to throw things out the window. Just because it runs in prod right now doesn't mean it should forever, which is something that's kind of hard for us to come to terms with. I feel like we have to keep supporting things. It's not actually true, it turns out. So when we decide to defenestrate stuff, which is defenestrate is a verb which means to throw out the window, we don't always need to replace it. Like the question I asked earlier, what business value did it serve? So that, that audit and update script might not serve any value anymore. If you've got tools in place that handle it, just rip the whole thing out and don't worry about it, right? And that could be that the value proposition is no longer as strong, or that the risk, the cost of replacing the thing is too high, which again, you'll notice a theme here that there's trade-offs. So let's look at some of these ideas, right? Does it do a lot of things? The more things it does, the riskier it is to kind of work with. The harder it is to fix and update or to replace entirely. So sometimes it's just better to throw those things away. If it touches lots of systems, again, that risk profile goes up, becomes harder to manage. It's less probable now that you need to touch all those systems at the same time using the same thing in order to manage the issue. Often they're low value. That's a good time to throw stuff out. Like if it's really not providing, just get rid of it. If it's got a high impact on failure, might be just a good idea to replace that thing. And the fewer people understand it, the more likely it is to want to get rid of it. So we're not going to focus on what to do when you get rid of it, but I really want to talk very briefly about something called the Strangler vine pattern, as described by Martin Fowler. So the idea behind this is that you have this big, vast application that touches a lot of stuff. It's kind of all through everything. You can't just rip it all out day one, right? Like that won't work. Everything will fall apart. You'll start getting yelled at. So what do you do instead? Well, if I know that there's a part of it that manages the warehouse database, I just redo that functionality. I figure out what we need to do to manage the warehouse database, introduce a feature flag to the existing thing to turn it off, switch over that control. So what you do is you add pieces of functionality that are smaller, more tightly scoped, more easily maintained, and those things eat away at the core functionality of the thing you're replacing over time. Kind of like a strangler vine kills a tree. It comes up and it takes a branch, and it takes a branch, and it takes a branch, and then before you know it, the tree is dead. Long live your legacy code. So the other thing that this implies is that every code that you've written turns into legacy code. You need to think about how you're going to kill that code at some point in the future. It's going to be replaced. It's not going to last forever. So anybody here responsible for OS deployments, right? How many of you, when you do OS deployments, include the OS deprovisioning in 10 years as part of like the architecture plan for that? Yeah, right? Like we all know it. Like it's pretty clear. Like we all deployed 2003 at some point, and then we got rid of it. We deployed 2008, and we're hopefully getting rid of it. Please. And then people are deploying 2016 today. So like we see this pattern. We're going to deploy things. They're going to be deprecated. They're going to lose support. They're going to be unsafe to run. We need to design and architect our systems such that we can kill them and replace them later. Question?
Yeah, sorry to interrupt you so early. Where's the line drawn?
If only I had an answer for that. No, so that's a good question. I should have brought that up. So legacy code is anything that exists in your environment that doesn't have tests, right, or doesn't have tests that everybody feels relatively comfortable with. That's lacking in documentation. You'll notice that the things that are like true about legacy code are the things that we're going to triage today. That's what we're going to go through. So speaking of triaging things and fixing stuff up, when do you doctor it? This is pretty nebulous. This is hard. This is always going to depend on context. And not every tool that you have needs to be doctored fully. So we're going to go through like a list of things that are going to help. You don't have to do all of them for everything, right? The lower the value, the less stuff you should do. And not all the steps are going to be as valuable as each other. So you might find times where tests are more valuable or documentation is more valuable. So if it does a few things and it touches some systems, it's medium to high value and it's medium to high impact. These are good targets for doctoring, right? It does something that's still valuable, something that can be pretty impactful if it goes down but isn't necessarily. It's going to come back a lot to business decisions inside of your organization and how you prioritize work, which is a really, really hard question that nobody solves all the way. The thing to look at, though, here is that this is all about trade-offs and not checklists. Like, you'll notice, like, I didn't give you, like, here's, like, step 1, check this, step 2, check, like, because that doesn't work. I could give you a checklist, it'd be garbage. You wouldn't be able to use it for more than, like, 1 or 2 projects, and you'd find out that it didn't work, find me, stab me. I don't want that. So keep in mind, everything that we're talking about here is contextual, and it's always going to play back to your organization and your team. Especially the skills on your team. If you don't have people who are capable of writing tests, some of the stuff is going to require skilling up, or it's going to require like a different understanding of how you approach these problems. Speaking of approaching these problems, so aside from checklists, I'm about to give you a checklist. We're going to go through this stuff. So the first thing we're going to do is make sense of the code. It's pretty hard to do literally anything else if you don't understand what's happening. And then we're going to document that code for future users. Specifically for the people who are going to use the code in the future, right? Then we're going to characterize current behavior, figure out what it's doing right now. And we're going to do a minimal refactor. What's the smallest amount of work that we have to do to make the thing safe? And then we're going to do iterative improvement. So the great thing is once you've set up for this, it's not legacy code anymore. You can just improve on it kind of as you please, right? All the stuff that has turned out to be things that you'd like to improve or change or add or whatever, all that stuff becomes available to you. So this is a real script that somebody gave me that I'm going to see if I can scroll through here. Yeah, it'll let me scroll. Right? Do you see it? Oh, you don't. That's great. Let's move my hand over. Nope. Nope. All right. Well, you're going to have to trust me that this is like 100 lines of garbage. It's long and terrible, and what it does is it's an AD cleanup script. I had somebody in the community send me an AD cleanup script that really runs in prod. We scrubbed it, made sure that there was no identifying information. So that's what this is going to go through. Is we're going to add a little bit of safety. We're going to triage this script. Looking through this file, it's kind of confusing to see what's happening. The naming's kind of weird. The extra stuff in here is kind of weird. So we're going to go step by step and try to make sense of it. So the first thing we're going to do is we're going to do inline commenting. As we're going through and making sense of stuff, we're going to go ahead and document what we've discovered. We're going to clarify this stuff for the future maintainer, right? Again, there's a different audience here. Maintainers and users are not the same. How many people here write scripts for other people in their organization to use? Right? How many of the users in your organization actually like read through the scripts that you give them? Anybody? So you've got some? Fair. Like a handful, right? But largely they're not the same people, right? They're not at the same level of skill or sophistication. So it's harder to just tell them, read through the code, you'll get it. They don't like that, and they shouldn't have to deal with that. The other thing to keep in mind is that it's a lot better to be thorough for now. Line comments don't cost you anything. You can rip them out later, right? Once there's a big enough understanding on the team and you know how it works, you don't have to keep it. So let's look at a few of these comments. This is just a smattering, right? I went through, I read through the whole script, figured out what it does. So it looks for a user and computer accounts which are inactive and tries to disable them, right, if they haven't been logged into for 45 or 60 days. And then it looks for stale user and computer accounts which have been disabled for more than half a year, and then it tries to delete them. It produces a CSV of logs for us to use in reports. So that's basically what it's doing. So this first piece here is a long note that explains what's up with dot sourcing, like what are these functions, like why is it doing this, and what those imported functions do, because there's nothing else in here that tells you. This is going to reduce your need to introspect across multiple files, which just a human nature thing. If I have to go to more than one place to read the docs, I certainly won't. I'm just not going to do it. I'll forget, or I won't care. I'll go, it's not that important. And that's just human nature, and we should design for that. Next piece, so you'll notice that there's a commented out line at the very bottom, the disabled accounts one. So the way of deciding whether or not the script will delete stale user accounts is whether or not this line is commented, which is great, super great. Did you remember? No, okay. So this is an added comment that warns you about that and then lets us kind of like, we shouldn't do this. And then this time, you'll notice at the far end, what if is also commented out. So another great implementation. In order for you to run this in what if mode, you've got to uncomment it and run it. But you'll also note that when they gave it to me, it was commented out, which means that by default, people are running this in apply mode, right? They're having it do stuff. It's not in null operations. So that's something. There's also a note here that tells you that actually the result code that it stores is not great. Did it run or not? It doesn't actually tell you anything except whether or not that command errored, which is not super great. It's not very granular. I don't get a lot of information. So we've got a little bit of an understanding of what the script is doing. We're going to talk about documenting for future users. So this is something different. This is reference documentation. Hands up if you know who June Blender is. Right, hopefully that number will go up. June Blender is an amazing human who has written endless amounts of information on PowerShell help and the reference documentation system inside of it. Everything I say pales to that, so don't talk to me, talk to June. I don't think she's here though, so I'll be a poor substitute. So reference documentation covers a few things: synopsis and description, your parameters, input and output is particularly important. That lets us know as users what I can expect to come out of this thing and what stuff it's going to take. We underestimate how important that can be for people. Examples are also critical. It lets people know exactly how you want them to use it in prod. So I don't know if this is clear, but if you write an example, people will copy and paste that example in production, right? So be mindful of that. Don't stick production databases in your examples because they'll do it. Then there's notes, which are pretty important for like letting you know kind of information as you update the script. And then the last piece of reference documentation here is a Readme, which we're going to cover super briefly. So of course, we've got the synopsis and the description, which I'm not going to linger too deeply on. We know that a synopsis is a short description, and the description is a long thing that explains what it does. So the important thing to call out here is that this description is actually explaining why the thing exists and some really important information that you should know, like, hey, this thing doesn't run in what-if mode. Be mindful of that. Because most people will not go read implementation and look at that inline commenting, right? So we want to warn them at the first place they're going to see it, which is the description. This is typically what everybody's going to see and read. And we do as detailed information as we can about the parameters. So in this case, their named exceptions list is kind of goofy. They store the exceptions in a text file on disk in a very specific spot. And if you want to accept something, if you pass a single name, it ignores the rest of the exceptions list and only accepts the one you passed, which is bad. So you've got a list of like 30 things that are accepted, like don't delete or disable these ones, except it won't do that if you pass any additional one. So you need to like pull in that list and add an extra name. The whole thing's really rough. And then we cover inputs and outputs. The first thing to note is that it doesn't work in the pipeline. So don't try it. And then the second thing to note is that the output is just integers. So this code tells you how many accounts it's going to disable and then how many accounts it's going to delete. So it'll output integers twice, which is not the most helpful output you've ever seen. Then we do an example. This is like straight out of the examples that he gave me. So you've added another exception, and like I was talking about earlier, it definitely doesn't include the rest of the exceptions list, which we annotate in the example. If you're showing people something dangerous, you always want to remind them how dangerous it is so they don't do it. Granted, there's still certainly people in their organization who just copy this and then run it. Like, oh, well, it accepted Jane Doe and no one else. We don't have a Jane Doe? Oops. So then notes give a little bit of information about background, why this thing is, where this thing is, and what you're working on. This is still technically user-facing. It lets them know that there's work upcoming. But then the important thing here, the thing I really want to highlight, is that you have this notes section, which is a checklist of stuff that you're going to do. If you don't have a source control system or anywhere else to store stuff, hands up, does anybody here use source control? Holy shit, that's really nice. Can I curse? Too late. Okay. So that took me off guard. I was expecting like 4 hands. That's good. Okay, so you have that, so you have a ticketing system, so maybe you don't need this as bad. This is still great because it lives in one spot and they'll see it whenever they do the help. It's a good reminder. And the last thing is, these are all fake, of course, but link to the things that derived this script. So in this case, like there's some security sections that they have that's like, hey, like if an account has existed and hasn't been logged into for 30 days, it needs to be disabled. If it's been disabled for more than 181, it needs to be deleted, right? So just point people back to those internal documentation pieces as well. All right, so the README, this is going to be really fast. There's an overview, a first use, getting help, installing, and a to-do. But the only stuff we're going to cover today is the first 30 seconds. So this is the first 30-second stuff. This is really, really important. When people read your READMEs, you have less than a minute to get information to them before they're going to start to glaze over and forget. So what you want to do is explain what the thing is and what they're trying to do with it, how they can use it. There's narrative happy paths and stuff later on, but the other nice thing is in a README, especially if you're using Markdown, is anybody using GitHub or GitLab? Fair amount of people. See, you're getting it. I don't have to tell you to put your hands up anymore. For those of you who are using that, if you use this syntax where you have the dash and then the open brackets, that annotates a check mark, and then you can check those off as you go, and it shows a visual representation to them of what's been accomplished, right? Most people, again, won't go read your issues. So that's all we're going to do for READMEs today. The next thing to talk about, and this is going to take up a lot of our time, is characterizing current behavior. So to do that, we're going to talk about characterization tests. There's a gentleman at the back, silver-haired. He has a Beyond Pester 101 talk that talks about this. Yeah, and then he's got another one up this week that you should go see. That's Glenn Sardi at the back. But characterization tests, these describe your current behavior, not very specifically, not intended behavior, right? When you write these tests, all you want to verify is that this is exactly what it is doing now. And why is that? Well, because that might not be the right thing, but that's the thing that's been running in production for the last 5 years, and you probably shouldn't just change it all nimbly-bimbly. You're also characterizing, you're writing tests to explain what it's doing, not how it's doing those things, right? I don't care about the internal details. All that I want to know is what is this thing going to do when I unleash it in prod? And the answer is probably disable and delete a lot of things because I can't specify what if. And then the other thing that this does is it prepares you for refactoring. If I know exactly what it is doing and I have tests that can verify that behavior, then I can change things and run the tests and see if I've changed the behavior. Because during a refactor, we don't want to change behavior. We just want to clean things up internally. And then the great thing is that once you have these, you can very easily convert them over to behavioral tests afterwards, where you'll be able to use those to say, this is what I want it to do. Now I will change the code until it does those things. So this is pretty gross. Here, we're looking really quickly through things. So the first thing here is that this is just your overhead setup for Pester. I'm not going to teach you Pester, sorry. This is the first describe block. The way that I do these is I typically do like the name of the thing that I'm going to be testing or characterizing. And then the context, the first one that we care about is the default behavior. What does it do if you pass absolutely nothing to it? And that's what these tests are going to cover. But the first thing is we have to do a bunch of mocking. So that exceptions list, one of the implementation details is that it retrieves a file on disk, which if you don't have, it'll yell at you and error out. So we pretend that any call to get content returns accepted. Then we mock get aged accounts, which is that private function that it was dot sourcing. Here we're just going to tell it, hey, just throw me back a bunch of things that have a distinguished name, one of which is the accepted one. So we'll always have one that'll be in the exceptions list. And then we do the same thing for mocking our calls to AD. How many people think it's a good idea to actually run disable against AD when you're testing? Is that good? Bad? It's bad. OK. And the last thing we mock is the export CSV. We don't care. We're not interested in what the log's going to be. We just want to verify the behavior in AD because we have limited resources. So the first context here is when it's attempting to retrieve all the accounts to disable. And we look inside. And we've got a couple of things that it works on. So it's attempting to retrieve accounts to delete. In this case, right, before all, we run the script. That's what the ampersand here, system under test piece is. And then we have a very simple test, which is it's not going to look for user accounts at all, right? That part was commented out, we saw. Okay, so right now, if you just run the script and change nothing, we want to make sure that get disabled accounts never ever calls with the account type of user. Never ever. It should never look for user accounts to pull in. And then we go through some of the other features that it has. So it can target alternate DCs. This is something to be mindful of for Pester in general. So little note, if you're mocking commands that don't exist on your machine, you also have to give them parameters that you need to have mocked because it doesn't know. You'll get an error if you try to pass server to something that doesn't have a server parameter. So in this case, I had to add that. And then you have like the context of providing an alternate exceptions list. And then finally, the important thing, the nice thing, is you get this nice green set of text whenever you run the tests that tells you, hey, it does all the things that you verified it does, right? And remember, this is important because we want to rerun this every time we're going to do any refactoring or changing to our stuff. We want to keep the safe. We want to make sure that the behavior doesn't change, right? So we figured out what its character is, bad, and we've annotated that in tests, and we can verify it. So refactoring. When we refactor stuff, the first thing we're going to look for is refactoring with clarity. The thing to keep in mind with refactoring is it's changing your code without changing the behavior. You're changing the internals, but from the outside perspective, once you leave that unit, there's nothing that's changed, right? So we should be able to run that exact same set of tests after every change we make here, and nothing should be broken, right? It should be all the exact same behavior. But the first thing we want to refactor for is clarity. We want to make it easier when you open that thing up to understand what's happening. We want to make it very, very clear, not just to us, but to future maintainers. Has anybody ever gotten code from a coworker and been like, I got nothing. I have no. It's going to be an hour, right? So, you know that that's going to happen. You know that you're going to have to hand this script off. Does anybody plan to stay at their work for the next 200 years? No. No. Okay. So, thought I saw a hand go up. I was real concerned. Well, there's immortals here. So this is going to help future maintainers, but also people who onboard to your team. If your team's never going to hire again, maybe you don't care, but probably they will. And so being able to help those folks to understand code is important. So here we have what it was before, and then really briefly, the only change is we refactored things into begin, process, and end blocks. Semantically, it's easier to follow, and it sets us up a little bit for the behavior change of being able to run things in the pipeline. But that's all that really changed here. We also made a minor change of using PS script root to stop require running from a specific directory. This is probably a mistake on my part, but it was driving me absolutely bonkers when I was trying to run testing. It just flat out didn't work if I wasn't in the right directory. And so here we have how it did the queries when it was looking for user accounts to find out which ones were old and needed to be disabled. So this, kind of hard to read, get aged accounts, doesn't tell me anything about what they're going to do with it. What we did instead was a little bit twofold. So we turned it into a set of hash tables that we can use for splatting later that are easier to follow and include inline comments to explain what each of those things does. So again, this keeps you from having to go and look at the other functions. And then the next thing that we did was we renamed these variables to something useful. Aged accounts doesn't tell me anything. I don't know what you're going to do with aged accounts. Accounts to disable is pretty unambiguous. If it's in this list, I'm going to try to disable it. And then we use splatting in order to reuse those hash tables from earlier. So this is the logic for disabling the accounts, and it's something. It certainly is on disk. So we do a couple of really brief things, sorry. We do a couple of really brief things where we're preparing for splatting our add member command. So if we go back, you see that there's a, does it not scroll all the way? That's fine, don't worry about it. So at the end of it, it updates the objects that it received in order to tell you whether or not it succeeded or failed and what that kind of stuff looks like. So all we do is we prep for that up top because that is fundamentally reused in both cases, in both loops, right? So a little bit of simplification here. And then we rename that loop to something less ambiguous. So again, if we go back, we saw that it was aged accounts, which again doesn't tell us anything. When we go forward, it's for each account in accounts to disable. Again, tells me exactly what it's going to try to do. That's important. The next thing is that it's going to inherit that hash table that we set up earlier. Something to keep in mind is that if you just assign it, it overwrites. You need to use clone, as I do on that first line. Thanks, Glenn, for pointing that out in the middle of one of my demos. And then we go ahead and we set those things. So we set input object to the account. It's going to behave on those ones. And then we run once for the named exceptions again, using functionally the same code. All we've done is just update the pointers and make things a little more readable and followable. This is all functionally identical whenever we go to the delete call, but it's going to disable the account and save the results and write them into the account's information. Because remember, it's writing back to the input thing. For some reason, they didn't create like a new, they just updated whatever their query information was. But I don't want to change behavior, I just want to make it easier to follow. And again, this is all functionally identical in the delete call, which is why our next refactor is going to be pretty fun. But so then we run the tests and we see, hey, isn't that neat? It turns out we can run the tests. They're all green again. Trust me on this, I ran it in all the right folders until I made it work. So then we're going to refactor. We've done clarity. We need maintainability, right? Because there's a lot of duplicate code hidden in here. So the first thing is we look at each account and accounts to disable. This is almost identical to the delete call. So how do we fix it? We go ahead and have it run for the same piece. So the exceptions logic is exactly the same. There's no difference between it, right? It just checks to see if that account's distinguished name is in the exceptions list. So we reuse all that top piece, and then down in that else, once it's time to act, this is how it looked before, right? We had where we just handle one. The only difference now is that we have some logic that says like, hey, is this thing in the accounts to disable or the accounts to delete? If it's in disable, disable it. If it's in delete, delete it. Update the stuff as necessary. So we unified that one thing down into logic so you don't have to change a whole bunch of duplicate code. And then again, of course, the important thing, we ran the tests. So we've done refactoring to make things a little bit more clear and maintainable. Now it's time to improve, right? We're ready to start changing behavior. Let's drive some value into this. So we're going to add what if support, because that one really, really sketches me out like a lot. So we're gonna fix what if. We're gonna add safety. It's the first thing we're gonna do. This is probably the most important one, the one that they ask for all the time, right? This is gonna help us because we're not gonna have to touch the script to change behavior. That's a really bad anti-pattern. If you have to update the script before you can run it, that's a really good sign that it needs to be fixed. So what do we do to support what if? It's complicated stuff, y'all. Take a look. What changed? What do we do? That's it. That's the whole thing. The only thing you have to do is just add support should process because the commands that they're calling supported what if. They didn't have to re-implement it or anything. Just those two commands already supported it. So ta-da, you did the thing. We come down here, and this is what we had before, right? Remove the warning because we don't need it anymore, and what if will just get passed through if you pass it at the top level. You don't have to worry about that anymore. You can cut out all that extra code. So now all we have is the warning about the results here. When we run the tests again, everything passes. Why? Because we didn't have any tests around what if because we couldn't have any tests around what if. But we're also not going to add any because there's no value in you verifying that PowerShell has implemented what if correctly in commands that you didn't write. That's a waste of your time. So remember, you only have limited time and space and availability to do your refactoring and your improvements, right? You got other stuff you've got to work on. So the next thing we're going to do is we're going to handle deleting users because remember, that's also commented out. If you want to do that, you got to fix it. So how do we fix that? Here's what we had before, right? So what we got now. We just added a single parameter for delete users. Just added a switch. So we previously had this under accounts to delete. And so the only thing that's going to change here is now we check to see if you set that flag. You set that flag, add that account. Otherwise, don't, right? pretty straightforward, but now we have to add a test, right? And so we add a test, we say, so when you're deleting user accounts and you're deleting inactive accounts, it's using the same test information that we had before, all that same scaffolding and setup. We just made sure we could add a new test that was going to verify things for us. So we wanted to verify that when and only when you say, when you pass that flag, is it going to try to delete user accounts. So the thing that this sets you up for is a bunch of scaffolding, right? You've got your script, you've made it usable for yourself and for future maintainers, you've made sure that the users are covered because you've got documentation laid out, you've gone through and added characterization tests, which now we can use to change behavior if we want. We can add more tests or change those tests. You've got some safety, you fixed some pretty glaring bugs, everything's here. You can actually reuse that test suite and just keep going, right? There's a whole checklist of stuff that I wrote down that could be improved in this script. You can keep going, or now that you've reached this point, you don't have to. You can go off and do something else instead. You're not forced to like go all the way. I said before that there's a bunch of trade-offs. How many of you have infinite time? Okay, yeah, that many. So that being the case, like you get it to good enough and then switch over. This is also a skill set that you're going to acquire over time, right? Like carpenters don't show up day one as like really good carpenters. They show up and carry wood and help out a little bit at first. So when you're advancing the skill, as with any other skill, you're going to find that you get better and dialed in over time. How much triage something needs, how much time it's going to take, what things are worth saving, what things are worth replacing. You're going to get better at all that. But this is a skill set that you can build on top of and will make you better at writing net new stuff, right? As you go through this triage process, you're going to understand like, hey, I just implemented some extra logic. I need to make sure that this is documented somewhere because eventually I'm going to win the lottery and stop showing up to work. So this being the case, right, it's a cool skill. It's got a lot of scaffolding. Let's talk about the elephant in the room, right? Those steps I lined out, those are pretty straightforward. Document the thing, document it for users, add tests, fix stuff. So why don't we do it, right? If it's simple, why doesn't it happen? So simple does not mean low effort, does not mean low skill, right? Easy to describe does not mean easy to implement, right? You can come up with great ideas that are really hard to implement. This also suffers from the same problem that everything else in our organizations do. If you're in operations, you're pretty familiar with that trade-off of tech debt versus ongoing stuff, right? It's the same problem you often have for like, how do I get them to let me automate like these old manual processes? So one thing that I could suggest is a book called Making Work Visible, which will help you kind of be able to make people more aware of these things, kind of show the value of what you're doing, and make working on things more visible to people so they understand the costs of the way that they currently do work. But this is all trade-offs, right? And it's hard and it's complicated, and a lot of it's going to come back to people stuff, which somebody is going to talk to you about tomorrow. There's a guy doing a D&D talk at 2 o'clock in this room. He's got a red beard. He probably won't be wearing a purple shirt. He will be wearing a tie, though. So it's hard, but it is also, in addition to being really, really hard, valuable. This sets you up for what we talk about often as like a virtuous cycle, right? We all know about death spirals, right? Anybody not familiar? Yeah, okay. So virtuous cycles are pretty much the opposite, where you've got these small iterative feedback loops where things get better and better and better and better and better over time, right? So you'll hear people like me say fairly frequently, slow is smooth, smooth is fast, fast is safe, which sounds like absolute and utter nonsense until you've seen it work. It sounds goofy, but the truth is, like, we go really, really fast, we break a lot of stuff, we incur a lot of debt, everything's kind of on fire. Say, okay, we're going to slow down, we're going to do more tech debt, we're going to start fixing some of the stuff in our environment. And you notice that fires start popping up more rarely. You figured stuff out a little bit. You've got a better understanding of how things work. You got a little bit more time. You triage more stuff. You can do more stuff that you're building net new. You've learned how to build those systems a little bit better. You're making smaller things that are easier to replace. And over time, it turns out that going slower at first meant that you could go faster and do more things more fast. And that as you're doing these tiny things, that's a lot safer, because if the tiny thing breaks, it doesn't take down the entire environment like that one script that does your user provisioning and server provisioning and deprovisioning and auditing, right? Like that script's super dangerous. But the thing to keep in mind is that this is all iterative, not incremental. And so the way that this is described, I think originally by Adam Jacobs, he may have stole it from somewhere, probably not, is so like if somebody comes to you and they're like, hey, I want you to do the Mona Lisa, right? you wouldn't start by being like, all right, cool, so I'm going to do the bottom left corner, and you tell me if that's good, and then I'll do like the left middle section, and then we'll go from there. Like doing it in a grid is a horrible idea, right? What you do is you draw a picture of a woman and be like, is this kind of close? And be like, yeah, that's pretty close. And like, okay, cool, I'm going to set it in the Grand Canyon. No, that's not what I want, right? You want to find those things out iteratively as you go, and you make small changes, small improvements until like, so you wouldn't start by doing like the full detailed painting. It's the same thing with our scripts, right? We show up and we try to like do everything all at once, all in detail of one chunk. And that's really hard, and it doesn't work, and it's very unscalable. But if you do something simple, you prove it out, and then you improve on it, you add more features, or you build new things, you get into a much better place. The other thing that these cycles allow us to do is affect our trade-offs over time, right? You're doing more in smaller pieces. You can come back to that trade-off you made earlier and decide, was this good? Did I make the right decision, or do I need to update on that? Do I need to change things? So you kind of end up in a spot where over time you're able to make those trade-offs and improve instead of always reacting at the end to, hey, everything's broken now, it's so bad that it hurts. You can just change it as the pressure changes. So that's all I have for you today. I've got a couple of resources here. All my talks stuff's going to go up online afterwards. So that's it. Thank you so much for attending.